Hello, chemistry. I felt rushed at the end of class, so I wanted to include one more problem. I've included the actual question itself for this problem, and so I wanted to work through this problem. I've created my IF table, IFE, I standing for initial, F standing for final, E standing for effect. Created that, and I'm just going to go through and fill out the problem. So it tells me Bobby blows 5 puffs of air. So that's initially talking about the number of particles. So over here, I'm going to say 5.0 puffs in a balloon. The temperature of the balloon is 25 degrees Celsius. And so remember, when I write this down in my IF table, I need to change that to Kelvin. So I'm going to add 273 to 25, and that's going to be 298 Kelvin. That takes up 450 milliliters. That's initial volume. And with a pressure of 2.5 atmospheres. So that's the initial pressure. So then it says, how many puffs does Bobby need? So that's what I'm going to be solving for. If the gas remained at 25 or 298 Kelvin, the volume changed to 850 milliliters, and the pressure changed to 1.0 atm. Well, we filled out this. Now we're going to look at the effect and try and predict what effect that has on N. The first thing I notice is, and so since temperature is not changing, I shouldn't see any effect on here, so I can just completely get rid of that out of the problem. Let's look at pressure. And because there's two variables that changing, I'm wanting to see the effect on N, I'm going to create two different blanks here. One that indicates the effect that pressure is going to have and one that's volume is going to have. So pressure in this case starts at 2.5 and goes down to 1. That means I am decreasing it. Well, if I'm decreasing my pressure, then what's that mean about the number of particles? Well, those guys are directly proportional, which means if one goes down, the other must go down by the same amount. Okay? Volume, however, it starts at 450 and goes up to 850. Therefore, it is increasing. And the relationship between volume and N is directly proportional as well. So it's also going to go up. So to solve this, we've got two things that we've got to consider. I'm going to start with my 5 puffs, and I'm just going to write 5 puffs, just like that. Now let's start with the pressure here. This part here, which indicates this pressure here. I need to multiply this by a ratio that is going to give me a smaller number because I'm predicting a decrease in my number of particles. And so I can either go 2.5 over 1 or 1 over 2.5. Well, if I went 1 over 2.5, that's going to give me a smaller number. So I'm going to take 1 divided by 2.5, and I'll show that my atmospheres cancel. You can go ahead and calculate that and write down the answer, but I would encourage you to hold off on that because we can now take care of this side. This represents the effect that volume has on the number of particles. If I'm predicting an increase, then I'm going to need a ratio of these volumes that's going to lead to a bigger number or a number greater than 1. In that case, I'd want to put 850 milliliters over 450 milliliters. My milliliters would cancel. Then all I have to do is calculate. So let me get my calculator real quick. Here it is. That was quick. Okay, to calculate this, I would take 5 times 1 times 850. Then I could equal. I'm going to leave that number in my calculator. Then I'm going to say divided by parentheses 2.5 times 450. Close parentheses equal. The final answer should be 3.777, so on and so forth. But because I need 2 sig figs, that should be 3.8 puffs. So no longer should the number of particles be 5, but instead this should be 3.8, and that would match these conditions of 1 atmosphere pressure and 850 milliliters. Hope that helps.